Good afternoon. So we are going to start with this assignment, which is coded assignment 4. Okay, so the first question is saying, state the mean value theorem for derivatives. State the mean value theorem for derivatives. Then prove the theorem you have just stated, which is proving the mean value theorem. From there, find the point C in the interval 2, 5. So that interval is open. So when the brackets are curled, then it means it's you're looking for the value in between. So in our case, we have got 2, 5, and the brackets are curled. So this means that you're looking for the numbers between 2 and 5. With respect to the equation or the function, which is f of x equals, which is f of x equals 2x squared minus 7x plus 10, satisfying the mean value theorem. So we are going to look at question 1 for this case. So the first thing that we are doing is to state the theorem. So the state, here we go. State the theorem, the mean value theorem for derivatives states that if a function f of x is continuous on the closed interval a, b and differentiable on the open interval a, b, then there exists at least one point C which belongs to the open interval such that the derivative of the function at that point, which is after you have differentiated and then you replace that point you're talking about to be in between the open interval, is equal to the average rate of change of the function over the interval. Then that's where the state ends. So if it's a state, okay, we can say it's something that you have to master, but at times you have to understand it. So when they use the brackets, which are like boxes, it means you are starting from A and ending on B. But when they use brackets which are curled, like it looks like letter C, then it means you're looking for the value in between A and B. Then, when you say that the function is continuous, it means that the way it is, if you replace a value, you are going to get an answer. There is nowhere where you're going to find that below there is a fraction, then there is a 0 below. No. Or the 0 is a denominator. There is no such case. Then the function is continuous, the way it is, without differentiating it. If you replace values which you have selected, then it is continuous for those selected values. Then to be differentiable, it means that after you have differentiated the function and then you replace the values, it is giving you answers. So that is about those two statements. Continuous means the way the function is naturally, start replacing values considering a certain interval. You are able to get answers when it's continuous. Differentiable means the way the function is, start differentiating it, then you replace values depending on the interval. Interval just means starting from a certain value up to another value. That is an interval. I'm sure. Then, the other thing that I want to make clear is that when we say f prime, f and a comma on top, f prime of c, it means you have differentiated the original function of f and then you have replaced the c. That is what it means there. It is equal to f of b, meaning in the original function you replace b. So these a, b, and c, they are numbers. They will be numbers. So just for now you should treat them as letters, but they will be numbers. You'll be given an interval. So that is the case. Proof, that is number B now. Proof of the mean value theorem. To prove the mean value theorem, we use Rolle's theorem. So the way the mean value theorem is, there is another theorem which we call Rolle's theorem. So that is the one we are going to use to prove the mean value theorem. Rolle's theorem, Rolle's theorem talks about the starting point of the interval, which is A, and the end point of the interval, which is B. They are equal. What do I mean? If you replace them in your function, so if you get a number and another different number, and then you replace them in the same function, and then they give you the same answers, it means even those intervals are what? Equal. That's what it means. All right. We go again. So which guarantees that there is a point C. So for the Rolle's theorem, if you differentiate, you get, if you differentiate the function and then you replace a point which is between A and B, your answer should be a 0. That is what Rolle's theorem talks about. But the mean value theorem talks about if you differentiate and replace the value of your choice, which is between the starting interval and the ending point of the interval, they should be equal to f of b minus c, f of a over b minus c. So that is about that one. Okay, let me take you through this one. Define a new function. So you have already got the function, which is f. Now consider a new function which are calling g of x. So now let g of x satisfy the conditions of Rolle's theorem. What conditions does Rolle's theorem want? It wants f of b to be equal to f of a. It also wants, if you differentiate this function and replace the letter of your choice which is in between a and b, it should give you the answer what? 0. That is what Rolle's theorem wants. That is the situation. It also wants you to have a function which is differentiable as well as which is continuous. So that is about conditions of Rolle's theorem. So now we define g of x. I'm sure you're able to see what I'm reading. We define here. We define g of x as the difference between the original function f of x and the second line connecting the points. So that is the case. So now we have y minus f of a equals the mean value theorem times a minus c, x minus a. So just to write it properly, so here there is y minus f of a. So I've taken the f of a to the other side. Now we are having y equals f of a plus. So the other part which was already there has remained. We have just taken f of a to the other side and then we have made it to start. That is why you are able to see now y equals f of a plus f of b minus f of a over b minus a times x minus a. So the same one which was on top where it is starting, where we are saying using y minus, the only thing that we have done, we have taken the f of a to the other side and we have made it to start as it starts at that side. Okay, we verify conditions of Rolle's theorem. So Rolle's theorem, we talk about continuity of a function. The function should be continuous. Remember, I said if a function is continuous, it means you have a certain interval, and then if you replace every value in that function, you are able to get an answer. There is no situation where you are going to find undefined or error. No. If such a case is possible, then the function is continuous. That is to be continuous. Okay. Then what are we saying about continuity? We are saying since f of x is continuous on the open interval, on the closed interval. So if the boxes, the actual brackets, then it is a closed interval. And the second line is a polynomial. So remember one thing, all polynomials are what? Continuous. If they have given you a function which has got x squared, x power 4, 4x, x to the power 13, as long as it's polynomial, there is no fraction involved, then it is continuous automatically. So that is the same case for a straight line. A straight line is always what? Continuous. The function g of x, what is g of x? A difference of two continuous functions. So now, if you have got a function which is continuous, and you're subtracting a function which is continuous, then even your answer will be continuous, because it is coming from two completely continuous what? Functions. So if a function is continuous, you subtract something which is also continuous, even your answer will be continuous. That is the case. Differentiability. Since a function f of x is differentiable on the interval, even the difference will also be what? Differentiable. So most cases, all polynomials are continuous, all polynomials are differentiable. So what are we doing now? We are saying, at first here, it was just g of x equals f of x minus open bracket, whatever is inside there. Now we are differentiating those items. We are differentiating. So now you will see the x minus a to disappear, because a is a constant. The derivative of any constant is a what? Is a 0. So that is the case there. We come all the way up to here. Equal endpoints, checking value of g of x at a and b. So in this function, the original function, this function g of x, replace a here and also replace a wherever there is x. That is what has been done here at this point. So they have replaced a everywhere, and they have obtained that g of a is a 0. So now we already know that g of a and g of b are equal. Therefore, the answer will be 0 for g of b as well. The third condition for Rolle's theorem is what? Satisfied. Now apply Rolle's theorem, because g of x satisfies all the conditions of Rolle's theorem. We are now assuming that there must exist a point what? C. What is that point? If you differentiate the g, you should be able to get a what? A value. Sorry, if you differentiate a g and replace c, you should be getting a 0. So that is what? The case. So in our case, where we have g prime of x here, g prime of x, we replace a c there, and we say this particular part where we have replaced here, where I'm zooming out, g of x here. So g of x, if we replace a c, we have been told here that it is giving us here we have been told that g prime of c is a 0. So in our case, if we replace here g prime of c, we are getting a 0 for this value. So in short, replace a c everywhere now. We replace a c where there is x. So after doing that, we are coming here at this point. So this side there will be a 0. So that case, what does it mean? F prime of c will come this side. And then what is going to remain this side? It will be f of b minus f of a over b minus c. So just check properly. We know, we are saying by setting g prime of c to 0. So if it becomes a 0, this part to the left will have 0. Then we are going to shift, what is having a negative here? This big thing, which is f of b minus f of a over b minus a. If we take it to the other side, meaning f prime of c will remain as positive, and it will be equal to what is this side. So we have just intended to start with the f prime of c. But that is just the case. Just know that this guy moved to the other side and it was equal to f prime of c. But we have just started, instead of starting with a big guy, we have started with a f prime of c. So this is now where we have proven that f prime of c, there is a point C. So that is the proof. You should just go through nicely, step by step, understand continuous, understand when we say the difference, differentiability, just go through nicely. You see that, oh, it is well and good. So now let's check question C. Question C is saying, find the point C in the interval. Which interval? 2, 5. So this interval, when you have, I repeat, when the brackets are curled, it means it's open. Meaning, you want a value. In short, you are starting after 2 and ending before 5. You are starting after 2 and ending before 5. That is what it means when they use curled brackets. So what are you considering? You are considering the function 2x squared minus 7x plus 10. What are you looking for? Mean value theorem. So we are using the mean value theorem. What does the mean value theorem say? Mean value theorem, this is the one here. I'm zooming it out. This is the mean value theorem. It says that whatever function you have, differentiate it and put a c inside. Then it should be equal to original function. Which one is our original function? This one here. So we are going to be putting the first, what is our A? Our A is always the starting value, which is 2. Then our B in our case is what? 5. So when we say f of B, your case should be second value. When I say f of A, your case should be first value. So now, look at this formula. This one which is here. F prime. F prime means find the derivative. I believe you know how to differentiate. F prime of what? C. Meaning, get your function, differentiate it. Don't include f as you write. No. Get your original function, differentiate it. Where you have seen a c, where you have seen x, put a c. Then when they say f of b, get your original function, remove f and replace the second value. And then if they say f of a, it's your function. Whenever they say f of, just get your function. If you are f out, if it's saying f of x equals, ukwamba after equals, that is what you replace here. But what do you do? Where there is x, put a. Your a is not a, but the starting value. If it's 2,5, it's 2. If it's 4,9, it's 4. The starting value is a. If you do that correctly, so check here, our solution. I've stated properly here that we have got the function which is f of x equals to 2x squared minus 7x plus 10. What do we have? We have got 2, 5. I've said our a is 2 and our b is what? 5. So I've seen the formula and I've understood it. Here, this one, f prime of c, f of b minus f of a. So I should find whatever is in the formula and then replace it within the formula. That's how we use formula. So I'll find f of b, I'll find f of a, I'll find f prime of c. So here I go. F of a, what is a? It is 2. What is f of x? So in the original function, I start to replace what? 2, where there is x. And I've obtained the answer to be 4. F of b, I start to replace the second value. And I've obtained the answer to be what? 25. Average rate of change, meaning I replace now to the right side of this equation. So upper, this one, f of b minus f of a over b minus a, is the one we are calling what? The average rate of change. We have replaced there and we have obtained what? 7 for the entire right side. Now there is where we have said f prime of c there. So what do we do with f prime of c? We are just differentiating the function. So this function, which is here, 2x squared minus 7x plus 10. Drop the 2, it becomes 4x. Here we're going to get a 7. And then put a c where there's x. So that was what was being done here. 4x minus 7. And then put a what? A c where there is x in your answer. And then equate it to the answer we got, which was 7. In short, we are just now going back to the equation where it was f prime of c differentiate and put c where there is x, and then equate it to f of b minus c, f of a over b minus a. So that is what was done, and we found that sorry, here I don't know why I went back to x, but I was supposed to go with c all the way, and we found that our c was 7 over 2. Then now it's your duty to check this interval. Yes, we have obtained 7 over 2, which is equal to 3.5. But is it in between 2 and 5? If yes, then you are correct. If not, check props. So that is for question 1. I believe you have found something helpful. Just check through at your own time or at your own pace. All the best.